So we are going to use the first derivative to tell us something about the graph of the original function. The basic summary is this. If f prime of x is positive, then f is increasing. So, for example, ln of x, right, is always increasing, yes? You agree? We're always reading left to right, okay? And if I just draw a bunch of slopes on here, a bunch of tangent lines, you can see they're all positive, right? Do you see it? So even though we're starting with the function, right, we want to get the derivative and tell us what the function is doing. Okay? So for example, f of x is ln of x, right? F prime of x is what? 1 over x, right? On 0 to infinity, right? So no matter what number I put into 1 over x, no matter what positive number I put into 1 over x, the answer is positive, right? So the derivative is always positive. That means the function is always increasing, okay? If f prime of x is less than 0, then f is decreasing. And of course, we're cheating, and I don't mind cheating because they've been cheating forever with this stuff, meaning they could look at the function, they could graph functions pretty early by plotting points, right? Put in the x value, calculate the y value, put in an xx value, calculate the y value, right? Build your table, try and connect with a smooth curve, right? So long before calculators, you've been able to look at the function, but now I don't have to look at the function. I can just take the derivative of the function and know what the function is doing, right? So give me a function that's always decreasing. How about 1 over x, right? Y equals 1 over x is always decreasing. Do you agree? This part decreasing for sure, this part decreasing, right? Always reading left to right, yes? And what's my derivative here? Negative 1 over x squared, right? Yes? And look at that, x squared is always positive, right? So that negative out front means this derivative is always negative. When the derivative is negative, we know the function is always decreasing, right? When the derivative is positive, positive, my money in my bank is increasing, right? Yes? Positive people, right? Positive derivative means increasing function. Negative, decreasing, right? Losing money. So there it is. That's the first derivative test. But let's write a step-by-step up. Now we have a first derivative test actually tells us two things, where the function is increasing or decreasing and where there might be possible local mins or maxes, right? And we already talked about the mins and maxes when the derivative is 0 or the derivative is undefined, right? But if you think about it, this is before my step-by-step, sorry. Here's my function, right? Increasing here, yes? Decreasing here, yes? Which means I'm going to have what in between? What's going to be in between the increasing part and the decreasing part? Standing at the top, right? A local max. It might be the absolute highest part of the curve, but at least locally it's the high part of the curve. Right? Does that make sense? Like I'd be climbing up Mount Everest and I keep getting to certain heights and I have to go back down and go to certain heights and go back down. Every time I hit the top of something, we call it a local max. Meaning anyone's close to me, I'm at the highest point. Right? When I finally get to Everest, to the very top of Everest, if I'm not dead, then I'm at the highest possible point. Right? Is that true? Is Everest the highest? I think so. So again, the step-by-step, so this first derivative test is going to tell me increasing and decreasing intervals and if I have local mins or maxes. Okay? All right, sorry. Let me start my step by step here. Step one, graph the function. Step one in everything in this chapter, except for probably 4.1 related rates, you're graphing the function right away. Okay? So we're going to graph the function. Step two. Of course, when you graph the function, notice what's happening. Where is it increasing? Where is it decreasing? Where is there a top of a hill? Where is there a bottom of a valley, right? Step two, find f prime and the C1 values, the critical values of the first derivative. C1, critical for C1, first derivative. I'll have C2 values when I do a second derivative test. Critical for C2 for a second derivative, right? So find f prime and find the critical values of f prime, right? Create a sign table. Do you remember sign tables in pre-cal? Do you remember how horrible they were? You had to help put all the factors at the top. No, factors along the side, critical values in the columns, and then do test values to find out if the function was positive or negative. You remember that? It was hell. I hated it. So I've got a much simpler sign table now that you're graduated to calc. So we're going to create this sign table as a number line. You'll see what I mean when I do one. Now, whoever's here Friday might teach you differently. I don't care if you use their process. If they teach you this thing a little differently on Friday and they have a different process and you like that better, that's fine with me. If you find some nerd on YouTube that teaches it the way that you really get it and that's the process you want to use, I'm okay with that. Right? As long as what you're writing down is correct, I don't care. Step 4, test f prime values between the criticals. Left of, right of, and between, right? So you really, the number line should be the domain of the function. So if it's a polynomial, your number line is the whole number line, right? If it's a ln, the domain is from 0 to infinity exclusive, right? Is that making sense? You need to think about the domain of the function. That will create how big your sign table is. Step 5 is the worst part. Conclude. The sign of f prime. Oh, and when you do the test values, you can cheat. I know you all know how to evaluate a function. You don't have to show me you're evaluating the function, right? Sign of f prime on intervals gives the increasing or decreasing intervals of f. F prime changes signs and f of c exists tells us about a local min or max. So if it changes from increasing to decreasing and the top of the hill exists, it's a local max. If it changes from decreasing to increasing and the bottom of the hill valley exists, it's a local min, right? Is that making sense? Let's do one from the book. So I asked the sub, hopefully it's Dr. Early. I'm really praying that it'll be Dr. Early. Anybody been getting help from Dr. Early this semester? Yeah, really nice. Is it helpful? Great. hopefully it will be Dr. Early. I probably will send out an announcement once I know who's subbing. And if Dr. Early needs something, somebody help him. I know he's using a walker, so if he had to go ask someone to unlock the door, it would take him a while. So maybe someone else would go over to public safety and get the door unlocked. Or if he needed markers or something, right? Yes, please help him out. Now, the homework in chapter 4.3, section 4.3, is all first derivative test, second derivative test together. So it's a good idea for you just right now to grab one of the problems and just do the first derivative test, okay? And then when I give you homework in this section, I'll say 4.3, number 27, first derivative test only. I'll say 4.3, number 35, second derivative test only, right? Is that it? You get the idea? Because it's so much work. You'll see how much work it is to do one problem. It really kind of sucks. 4.3 exercises. So I like 19 to 45 is pretty good. Definitely do the trig, right? I guess 27 is fine to start. We don't have much time, so. Oh, you're going to have Kevin Johnson. Beautiful. Kevin is excellent. Great choice for Calc 2. Okay. So x squared ln of x, yes? So this is 4.3, number 27, first derivative test only. This one's not that bad. Some are pretty bad. So f of x is x squared ln of x. I think I can draw it. It's doing something like that. Maybe not. Sorry. I'll double check with the calculator in a second. I can't erase my memory. My memory's gone. What do I have running? The book, WebAssign, Blackboard. F of x equals x squared times the ln of x. That's close. Just put a little extra curve in here that I didn't need. Come on, erase. Damn it, erase. All right, how about cross out? Can I cross you out? There we go. Okay, crossed out. Nice. So I got my graph, right? I know I can't be, I can't have 0 because ln of 0 doesn't exist, right? Right, we okay with that? Ln of 0 can't happen, right? So I already know for my number line, I'm going to be talking about this number line, right? You with me? From all positives only, right? Good, derivative. I need a product rule, right? So f prime is what? X plus 2x ln of x. And of course I could factor out the x, and I get 1 plus 2 ln of x, yes? We agree with that? Good. Critical values. X is 0, but that's not in my domain, right? So no good. 0 does not belong to 0 to infinity exclusive, right? So no, that critical is no good for me. And then 1 plus 2 ln of x equals 0 gives me what? Ln of x is negative 1/2. So x is e to the minus 1/2. So x is 1 over the square root of e. And of course, 1 over square root of e does belong to 0 and to infinity. So that's the critical I want. Is this okay with everybody? This is okay? You okay with my critical value? Yep. Okay. Yeah, I raise, so I skipped a step here. I raise, in pre-cal, we know e to the x and ln of x are inverse functions. So we raise both sides to base e, right? And e and ln cancel each other because they're inverses, right? And negative exponent means reciprocal. And a half, exponent of a half is a square root. So I'm ready for my sign table now, right? I'm ready for my sign table. The only number I have on that sign table is 1 over square root of e. I have to check somewhere to the left and somewhere to the right, right? So 1 divided by second square root of e. Is 0.6. So so I can check 1 over e, and I can check e. Now I'm saying this part, you can kind of be lazy with this part. All I really need to know are the intervals from 0 to 1 over square root of e, and from 1 over square root of e to infinity, right? That's all I really need to know. I'm going to put these values in just so you can see it. What I really want you to do is just look at the graph and know that the function, the first derivative is going to be negative here and positive here. Remember, I'm checking the first derivative. So when the first derivative is negative, what's the function doing? When the first derivative is negative, what's the function doing? Decreasing. So I'm really just looking at that curve to see where is it decreasing, right? And where is it increasing? And where is, what special value is that? It's 1 over square root of e, right? Yes, you with me? So I really can cheat this compared to what I did in pre-cal. Once I have my sign table done, I'm ready for my conclusion. So here we go, conclusion. Oh, do you want to see me evaluate at 1 over? So what's my derivative? Sorry, I forgot. What's my derivative? Oh, f prime of x was x plus 2x ln of x, right? So when I put in E, I get E plus 2E times the ln of E. ln of E is 1, right? So I get 3E positive. You see? Do you really have to do that? You're a calculus student. You don't need to. I know you know how to evaluate functions, right? So cheat. Conclusion. Since f prime of x is negative on the interval 0 to 1 over square root of e, f of x is increasing on that interval. You can see why this stuff, it's easy. Am I right? This is easy. We've done all of this. All we're doing is finding derivatives, finding critical values, right? That's it. Yeah? Brian, no, you good? But it's a pain to do the problem. I'm sorry, not increasing, decreasing. Thank you. Millian gave me a look like, what? Since f prime of x is positive on 1 over square root of e to infinity. And by the way, these intervals will always be open intervals. They'll never be closed, okay? Since f prime of x is positive on the interval from 1 over square root of e to infinity, f is increasing on that interval. There's my increasing, decreasing conclusion. Now I need my local min or max conclusion. And we clearly know it's a local min, right? We can see it on the curve, yes? Since f prime of x changes signs from negative to positive, at 1 over square root of e, comma, I'm just doing a quick side work here. 1 over square root of e squared ln of 1 over square root of e. That's 1 over e times a negative 1/2, negative 1 over 2e. To get the local min or max, I need to put the critical value from the first derivative into the original function to get the height of the point on the, right? So I'm using the sine table to check the derivative, but I'm using the original function to find the actual points, okay? Since f prime of x changes signs from negative to positive at that point, right, we know that point is a local min. Done. Can you see why I said it gives you a headache? A lot of writing. A lot of writing. The biggest mistake I see on this test coming up is you don't give me a conclusion. So you got me to critical, you got me to derivative, but you did nothing else. I don't know. 3 out of 10? I don't know. Conclusion is the big part of it. And then, of course, I like to check that I've got everything right here. What did I say? 1 divided by the square root of e, comma, negative 1 over 2e, right? Woo! I love it when I'm right. Doesn't happen often in my house. Only when I do math. Nice. Have a great day. I won't see you Friday, but there will be a sub here. Question? One more time? Yes. I believe Kevin Johnson will be here. It's great for you to experience him teaching because he's teaching Calc 2 next semester. I believe he'll also teach Calc 1 next semester. Question? Sorry, yes, sorry. Yes.